Good evening, ma'am.
Good evening, ma'am.
Hello everyone.
Good
Good
evening, ma'am.
evening. Good evening.
Good evening. Good
Hi
evening, ma'am.
everyone. What did we do
Good
last
evening,
class?
ma'am. Good evening, ma'am.
Good evening.
Ma'am, factors and multiples.
Good evening, ma'am.
Good evening, ma'am. Good morning,
Good
ma'am.
evening everyone. Good evening.
Good evening, ma'am.
Hi, good evening everyone. What did we do last class?
Good evening, ma'am.
Good evening. Factors and multiples set 1.
Ma'am, I have
Okay,
done
great.
the home.
Yeah, thank you for telling me. You all can tell me in the chat box if you have any doubts in factors and multiples set 1. Question numbers, you can type it in the chat box. I'll just close the chat box to myself. Done. Sadhana number 9. Okay, let me log in. No doubts from Aditi. Number 9 and 10. Sadhana 9 and 10. 3 and 7 from Anvita. Okay. Let me share my screen. 2, 3, 7, 9, 10 path. Okay. Today, if we finish the things on time, I have a new match for you people. We will be playing Game Kit, and there's a new game in Game Kit. We'll be playing that. Say Samriddhi.
Ma'am, I couldn't do my homework because in the Olympiad success, ma'am, I need my parents' ID for that. And ma'am, they were busy, that's why.
Okay, you ask them to give them once. Like once you know the ID and password, then you would not need it every time. Like you can
Yes,
just keep it somewhere. Okay, Samriddhi.
ma'am, they were busy in the office, that's why.
No problem, Samriddhi. You can do that this week and keep that written somewhere so that you don't have to ask them again. Okay, Madhulika. Yeah, say. Not Madhulika, probably. It's Aradhya.
Yes, ma'am. Ma'am, actually, are we going to do like all the doubts today? And then if we do early,
Yeah,
we can
yeah. All the doubts of factors and multiples today.
Yes, ma'am, I can.
Okay. And yeah, Manasvi, I remember there were some questions. Yeah, we can do that from the computation operation if. But then see, Manasvi, the problem which we face when we do older doubts here is that we lose the flow of the class here. Like we get late for the class. So if we are done with the questions, I'll first come and complete these questions. Otherwise, see, you will have to wait for the next discussion session, which is next class only. That is today is Wednesday. So Friday only we'll be having a discussion class, everyone. Why? Because factors and multiples, after we finish today's class, we will have a test discussion also. Say Ryanshi, then I'll go to Parth.
Ma'am, I couldn't complete my homework because I was not feeling well.
Okay. Take care. Now you're okay?
Yes, ma'am, a bit of okay.
All right then. Say Parth.
Ma'am, I didn't got board mass questions in the worksheets.
It's in computation operation Parth. So this is computation operation part 2. These
No,
are the
ma'am,
board
this
mark
I
questions.
have done. You were saying of the worksheets.
Okay, you go to
Ma'am, I have
worksheets. Under that, you select comprehensive mathematics. And from mathematics, see, all chapter names are coming here. Oh, yeah,
Ma'am,
this one, computation operation.
Ma'am, but my one was only showing UIMO.
Then you have to check with Olympiad Success Path. Okay, tell them they will set it for you.
Okay, ma'am.
Okay. Say Hanifa.
Ma'am, I couldn't do the homework because I have exams.
Okay.
I had to study.
Fine. Okay. But guys, in that case, if you're not doing the homework on time, then you will have to wait for the other doubt discussion day to come. Only then I'll be taking your doubts. Otherwise, then it will be like every day we'll be doing some or the other doubts because someone did not do the last homework last class. They did it after 2 classes. Then someone did it after 3 classes and they're coming for the doubts. So we'll have to fix it so that everyone does it on time. And in case you're not able to do it on time, no problem. You can wait for the next doubt discussion day. Okay, fine, everyone. Let me start with the doubts of today's class first. So question number 2 is the first doubt, and yeah, there are 6 minutes. Okay, so I'm clicking on stop, so I'll not be taking any more questions now. I'll start with question number 2, then go to 3, and then 6, 7, and then 9, 10. So 2 number. Let's start with the second question. We will start this one with Aditi. Aditi,
Yes, ma'am.
they are saying, what do you get on adding the number of factors of 56 with the number of factors of 66? So we have to count the number of factors. Can you tell me what are the factors of 56 you found?
Ma'am, the factors of 56 are 1, 2, 4, 7, 8, 28, 14, and 56.
And that is total how much?
1, 2, 6, 8. 8.
8 numbers. Similarly, Adya, can you tell me how many factors are there for 66?
Ma'am, I need to calculate for that.
Vedant, are there more factors for 66?
Ma'am, when I was calculating it, then now it was long time ago. Wait, ma'am, ma'am,
You're
60.
supposed to answer it right now only, not
Yes,
look
ma'am.
back to your answers.
Yes, ma'am. 66 has more.
More? Which are those? Shania, I'll come to you. Yeah, Vedant, which more?
Ma'am, there are more factors for 66.
What are the other factors? That's what I'm asking. Shania, are there more factors for 66?
Actually, no, ma'am, no, ma'am.
Okay, Vedant, your turn is over.
Ma'am, there are 8 factors for 66.
So all the 8 factors I've written on the screen.
No, ma'am.
Which one is missing?
Oh, wait. Sorry, I didn't see that. Yes, ma'am.
So that means there are 8 factors of a 66, and as per Aditi, we have 8 factors of 56 also. So if we add that, what do we get? 16. And that's the answer for this question. Whose doubt was question number 2? Whose doubt was question number 2? Yes, Pa, did you understand?
Yes, ma'am.
Okay. Mishika, did you understand? Now, number 3 is a doubt of Anvita and Parth both. So pay attention, both of you. Now we'll go to the third one. What do you get on subtracting the number of factors of 100? So you remember when we were doing in the class, last class we did 100. 100 is a square number. So the number of factors are odd factors. 9 factors. I actually remember it. Remember everyone, 9 factors were there. Yeah, I just remember it from the last class. Now what about 48? The number of factors for 48 will be 1 times 48, 2 times 24, 3 times 16, 4 times 12, 6 times 8, and stop because 8 times 6 is again repeated. So we have 10 factors. And they are saying that what do you get on subtracting 9 from 10? We get 1. So Parth and Anvita, is it clear? I got a thumbs up from Parth. Anvita?
Ma'am, we should subtract 9 from 10.
Yeah, 9 from 10. So the bigger number is 10. Smaller number is 9.
Ma'am, we should get the factors of 100 first,
Yeah, that is 9 factors.
and then the factors
Yep.
of 48.
Yes. And then subtract it.
Ma'am, the factors for 100, I got 4 only, ma'am.
We have done it in the class, Anvita. Remember?
And for
1
4,
times 100,
also got 4.
2 times 50. What?
Ma'am, for 100, I got 4 factors, and for 48 also
I'm
I got.
writing it, Anvita. Anvita, look at the screen. I'm writing something. What is this now? Count.
100
10 into 10. So 1 into 100, 2
How
into
many factors, Anvita?
ma'am, 5.
This is counted as 10 factors, Anvita. 1, 2, 3, 4, 5, 6, 7, 8. And this is counted 9 because 10 and 10 is same.
Yes, ma'am.
Sorry. Okay.
Ma'am,
Thank you.
good evening,
Say
ma'am.
some-
Good evening, ma'am.
Yes, Samriti. What happened?
I joined late today, so can you just tell what we were doing?
That they are doing doubt discussion factors and multiples. Set
Okay,
1.
ma'am. I'm sending my doubt.
1, 2, 3, 4, 5, 6, 7.
Anvita, did you understand? Every pair has 2 numbers in it. So what you're doing is you're just counting it once. Don't count it once. They are counted twice. Like 1 and 100 both can divide 100. 2 and 50 both can divide 100. So that's why we count it separately. Okay?
Okay,
ये
ma'am.
means count clearly separate.
Okay.
Ma'am,
Number 3 sorted.
separately.
Sorry.
Ma'am,
Say
what
that again.
count separately?
We count the numbers which multiply to give you 100 separately. So 1 is also a factor of 100. 100 is also a factor. 2 is also a factor of 100. 50 also divides 100. So 50 is also a factor. So you count all the numbers separately.
Yes, ma'am. For 100 also, for 48 also like that.
Yeah, that's how we wrote it here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? Right? Done? Okay. Fine. After this, the next out, number 3. After number 3, we have number 6, 7, 8. No, 6, 7, 9, 10. So number 6, let's go to the 6th question. P is the number of prime numbers between 100 and 110, both inclusive. Do not worry, 100 and 110 are not prime numbers. So anyways, it will not be helpful for us. We'll start with 101. Is it a prime number? Yes. 102 is not a prime number because it's even. 103 is a prime number? Yes. 104 is a prime number? Nope. Why? Because even. 105 is a prime number? No. Because it's divisible by 5. 106? No. Because it's even number. 107 is a prime number. 108 is even number. 109 is a prime number. And that's all. So we have exactly 4 prime numbers. So the P is the number of prime numbers. P is 4. Shanaya, this was your doubt, right? Clear? Say Parth.
Ma'am,
Yeah, Adya, don't ask to use the restroom. You guys can just go directly. Say Parth.
Ma'am, I was asking that the 7th question, is there any trick for it?
Which one? How many prime numbers are present? No, no tricks. You have to manually count and check. Okay? The
Okay,
only
ma'am.
thing is that if you remember some of the prime numbers, then it's easier. Otherwise, one thing which you all can check is you all can check the 6k plus 1 rule. But as we discussed in the last class, it's not always applicable. So it's a little bit risky. Okay, the people who are asking doubts for this one, have you people gone through this? I have a doubt in this one. Look at this. Manvik, you're unmuted. This is Mathematics Olympiad. This is Factors and Multiples. This is the answer key. So the questions which you people don't understand, can you ask your parents to check it, or you yourself can also, if you have access to the website, can check this part. Like, see, I can show you one number by writing it, but I believe that this is not something I can explain you. This is like a fixed number, whether a number is prime or not prime. So you have to check it by dividing it. That's how it takes your time. You have to see whether these numbers are divisible by other numbers or not. If they are not, then they are prime numbers. And that's exactly how you're going to count all the prime numbers between 77 and 139. So the answer key has all the answers in detail for you. So just next time, just try to visit this page once. If you still don't understand after looking at it, you can very well ask me. By the way, the people who had a doubt in the seventh one, the answer should be 12, because these are the numbers which are divisible. Okay, or these are the numbers which are prime. If you want to check this, please check this whether it is, what is the closest multiple of 6 closest to 79? Anyone? Closest multiple of 6 closest to 79? Yes, Shivani?
Ma'am, is it 66?
66 is slightly far. Come closer. More close is possible. Samriddhi?
72.
72. That's right. It's 6 times 9, everyone. But it is one more step ahead. Okay, go one more step ahead. What will you get when you go one more step ahead? 6 times? Oh, sorry, I wrote a 9. 6 times 12. And then 6 times 13.
78.
Say Sadhna.
Ma'am, 78.
78. Now this is the closest. So I can say 6k plus 1. That is 6 times 13 plus 1 gives me a 79. So like this, you all can check it. But I still think that if you use divisibility rule, we will be learning divisibility rule. So if you use divisibility rule, that will be more easier for you to go with this. Anyways, any doubt in the seventh one? No. Okay, then number 8. Number 8 was not a doubt of anyone. Number 9, I believe. Samriddhi, where are the doubts which you were talking about? Have you written any doubts?
I'm with Samriddhi.
Samriddhi, Shiva.
Ma'am, I've written 7.
Okay. Where is my laptop? Oh. Okay, fine. Let's go. Now the next one is number 9 and number 10. So we'll do number 9 and number 10. Number 9 and number 10 is very interesting. Please pay attention how to do this. So when we have a rectangular plot, we have a length and we have a breadth or width. Okay. The dimensions are always L into B. Why? Because the area is equals to L into B or L into W. So if the area is 122, what are the factors of 122, everyone? 1 times 122? 2 times 61? Are there more factors? That means there are 2 possibilities. That means there are 2 possibilities. What are the 2 possibilities? Possibility number 1 is 1 into 122 and possibility number 2 is 2 into 61. That in both the cases, I get the answer as 122. And that's how I will say that there are 2 dimensions possible. This is either length into breadth. This is length into breadth. 2 dimensions are possible, right? What will happen in the case of 144? Now, this is an intelligent question. Apply your brain. Say, Pat.
Ma'am, I didn't still understand the 9th.
See, in the 9th one, what we are doing, we are finding out what are the possible factors which multiply to give you the area as 122. So, those factors will be nothing but the dimensions. Dimensions are the length and the breadth of any rectangular area. So dimensions multiply with each other to give you the area. So what are the possible numbers which multiply with each other to give you 122 is what you have to find out. So there are 2 pairs possible path. First pair is when you either take the length as 1 or breadth as 1 and the other thing as 122. That multiplies and gives you 122 as the area. And the second case possible is where you take the length or the breadth as 2 and the other thing as 61. Even that will multiply to give you 122.
Ma'am, then why don't we have the answer 1?
1 is not the answer for 9 because there are two cases possible. So therefore not 1. 2 dimensions are possible. Two
Ma'am,
ways of getting the product as 122.
मैम यानी जितने पेयर्स होंगे मैम उतने ही उसके डायमेंशन होंगे.
Correct. Right. Okay. Say Samriddhi for the 9th one or 10th one.
I'm saying for the 10th one that it is a square garden, so a square garden would have all the like sides sides equal. So
Correct.
so it should be 12 into 12, which has one dimension.
Correct. If we go by 144, then 144 has a lot of factors, right? 144 has a lot of factors. But then 4 times 3 and then 12, 2, 4, 8. And there are more also. But the interesting fact is that we cannot take all these dimensions. Why can't we take all these dimensions? Because as Samriddhi said, all the 4 sides should be equal in a square and therefore the answer for a square garden will always be 1 dimension. Only one value is possible where the length and the breadth are absolutely same. Thank you, Samriddhi. Say Anvita.
Ma'am, we should for 122, we should get the factors, ma'am.
Yes.
Ma'am, with those factors, we only got 2, ma'am.
We got 2 factor pairs, Anvita.
So, ma'am, how did the answer be 1? I'm not.
The answer is 1 for 10. Not for 9. For 9, it's 2.
Yes, ma'am. How about just 2 for 9?
Because this is the first pair, 1 into 122. And this is the second pair, 2 into 61.
Ma'am, so we got 2 factors. So we put the answer as 2.
Yes, 2 dimensions.
Ma'am, but I don't understand the difference between the 9th question and the 10th question. They're both the
This
same.
is the difference between the 9th and the 10th question. One is a rectangular garden and the other is a square garden. So what is the property of square, Anvita?
Ma'am, it has 4 sides.
4 sides are present in a rectangle also, madam.
Yes, ma'am.
So what is the difference I am saying? How is a square different from a rectangle?
Ma'am, because it's not broad.
No, that's not a definition. What is a square? Square has all the 4 sides equal, Anvita. Have you learned that in school before?
Yes.
Yeah, so this is the right answer. Square has all the 4 sides equal, whereas rectangle does not have all the 4 sides equal. Therefore, all these dimensions.
Ma'am, shouldn't we factorize for this 10th one?
Even if we factorize for it, like I was doing over here, it's of no use because that would mean the length and the width are different in each of the cases, Anvita. Is it possible for a square to have the length and the width different?
Yes, ma'am.
No, ma'am.
No, ma'am.
How can the length and the width be different? The length and the width is only different for the case of a rectangle. This is the length, this is the width. But for a square, all the 4 sides are equal.
Equal.
Okay?
Ma'am, so it's just 1 square, so we're putting the answer as 1.
Absolutely. Whenever we see the square, we know that, ma'am, only 1 dimension is possible because the length and the width of the square is always
Equal.
same.
Same.
Got it now?
Yes, ma'am.
Okay. Thank you. Fine then, everyone. Let's go. There are no more questions, I think. Yeah. So let's go and start with the part 2. Part 2 is really important. Please try to understand this. We are going to learn 2 things today. Actually 3. The first one is prime factorization. The second one is HCF. Third one is LCM. So first, before we start with HCF, LCM, we'll first do prime factorization. So far, what type of factorization we were doing? normal factorization. Like we were trying to find out all the numbers which divide a particular number. But now we will only focus on prime numbers. We will focus how different prime numbers multiply within themselves to give us that number. So for that, you have to follow the process little carefully. So I'm sharing my screen. Please start making notes of it. Okay, you might need it. So let me share my screen first. And as I said, keep your notebook ready, please. And probably we'll need one extra class for this. Anyways, let's start with prime factorization first. So how to do prime factorization? The first thing is this, okay? So you take any number, let's say 10, okay? So when you're prime factorizing it, you should start with the smallest prime number you know which it can factorize. That means the smallest prime number which can divide 10. Is 2 the smallest prime number which can divide 10? Yes. Now, when you divide it, whatever your quotient is, please write it at the bottom. Whatever your quotient is, please write it at the bottom. So my quotient is 5, I'll write 5 here. Now, do you think that 2 divides 5 completely? No. The next prime number is 3. Is 3 dividing 5 completely? No. But 5 itself can divide 5 completely. And the moment you know or you get 1 at the bottom in the quotient, you know you have to stop here. And by stopping here, whatever prime numbers you have written on the left side, just go and simply multiply it. You will see that the product is always the number with which you started. This was the easiest example I could have given you. Why? Because it has only 2 prime numbers. If I give you the example on the screen, 1 second, Advika. If I give you the example on the screen, that is 24, you will see things repeating here. See, 24, 2 divides 24 leaves a 12. 2 divides 12 leaves a 6. 2 divides 6 gives a 3. 3 is not divisible by 2, but 3 is divisible by itself. The moment you get 1 in the place at the bottom, you know you have to stop there. And what is the next step? The next step is to multiply all the numbers on the left-hand side. What are the numbers on the left-hand side? 2 times 2 times 2 times 3. And if you actually multiply it, you will see you get 24. 2 times 2, 4. 4 times 2, 8. 8 times 3, 24. So this is the prime factorization. Since it's repeated 3 times, you can also write it as 2 to the power 3. Now ask your doubt, Advika.
Ma'am, what if the number that we're dividing it with, like how you took 10 and 24, what if it's a prime number?
It will not be divisible. It will be divisible only by itself. So prime numbers have only 2 factors, one in itself. So no prime factorization, just itself.
Okay,
Okay.
ma'am.
Say Vedant.
Ma'am, is this similar to factor tree?
A little bit, but factor tree is not sticking to prime numbers only, but this one sticks only to prime number. We can only keep prime numbers on the left hand side as a divisor. Okay. Say Anvita.
Ma'am, we should suppose there is 10 on the right side and 2 on the left side. We should 2 5 is 10, so we should keep 5 at the bottom.
Yes, yes.
And we will not get. Then why are we keeping again 5 there?
Because no other prime number divides 5, Anvita. 2 doesn't divide, 3 doesn't divide. So ultimately, it's only 5 which divides 5. No
Yes,
other number.
Thank you, I understood that. But under 10, why are we keeping 5 again?
This 5 was first. Like this 5 came first because when you divide 10 divided by 5, whatever you get as the quotient will come below it.
Okay, ma'am. At the bottom of 10.
Yes.
Even suppose if 10 is 12, 5 will come at the bottom.
No, 5 will not come at the bottom. No, if 10 is 12, then 6 will come at the bottom because 2 times 6
Yes,
is 12.
ma'am. Any number, but it will come at the bottom.
Yeah, it will come at the bottom.
Yes, ma'am. So,
Hmm.
so that I will write that 5 there and we'll just put that 1 here because it's 5 into 5. 5
Correct.
into 5.
Correct.
So we should
Okay,
stop because we can't do it anymore.
Yes. Okay, everyone, 20. Try it for 20, please. Send me the answer in the chat box. And if you are looking for a multiplication sign, then just put a X. Just put a X. So write 2x, 2x, whatever is your answer in the chat box. Yeah, Samriddhi Singh.
Ma'am, I couldn't hear what you said because of an internet issue.
Look at 24's example. When you do prime factorization, you try to find out which is the first prime number which completely divides 24. So 2 is that first prime number. So we write 2 here and we divide 24. Whatever we get as the quotient, like 2 multiplied with 12 gives you 24. So the quotient is 12. The quotient comes at the bottom. Then again we will check which number divides 12 completely, which prime number. Since 2 divides it, I'll again write a 6. Since 2 divides it, I'll write a 3. Now 3 is a prime number and I know that it cannot be divisible by any other number. So therefore, I'll divide it by the next prime number, which is 3 itself. The moment I get 1 as the quotient, I will stop there. And then, Samriddhi, I'll write down all the numbers on the left as a multiplicative form. And that's how we call it as prime factorization.
Okay, ma'am.
Okay. Very good. I've got 14 right answers in the chat box, which is very, very nice. Manvik, don't write x equals to 20. You write it in the form of multiplication, like which factors multiply, which prime numbers multiply to give you 20. Write it like that, Shania. Okay. Thank you, others. You have written it correctly. Part, same for you. Thank you. Thank you. Anvita, same for you. Janvi, don't write a 1 because 1 is not a prime number. So we first start with 2. We get a 10. Then we again put 2. We get a 5. And then we know 5 is not divisible by 2 or 3. So we'll directly put a 5. So the numbers are 2 into 2 into 5. Check it, everyone. That's how you write prime factorization of any number. 2 into 2 into 5. Any doubts? Ask. No? Okay, then do another number. Say Vedant.
Ma'am, when we write the multiplicative form, shall we write first the smallest prime numbers, then only the larger ones?
See, it is not mandatory because multiplication is commutative property. So it really doesn't matter you write 2 times 7 or 7 times 2. But if you write it in an ascending order, there is a very less chance of doing mistakes. That's why it's preferred. Okay?
Ascending order.
Yeah, like I'm starting with the smallest prime number, just like that.
Okay.
Okay? Okay, people, everyone, let's try this number. Okay, let's go. 132, a little bigger number for you. Shreya, and tell me the first prime number you want to divide it with.
Yes, ma'am.
Tell me the first prime number you want me to divide it with. Were you listening to the class when we were discussing this?
Yes, ma'am.
So tell me, what did we do here? You did not even answer for 20. Shreya, and
Ma'am,
even
you
if
did
the
not
class
call
is...
me that time.
Sorry?
You didn't call me at that time.
Yeah, I am not calling anyone. I asked everyone to type the answer in the chat box. Shreya, the
Yes, ma'am.
batch is big doesn't mean that I'm not paying attention to everyone. I can figure out the people who have not answered. Pay attention. I will come back to you. And the second time I ask you a question and you don't answer, that means totally you're doing something else in the class. Don't raise your
Okay,
hand if
ma'am.
you know the answer. The next time
Okay.
anyone does that, that person will not get chance to speak any answer in the coming class also, including today's. Say, Sanya.
Ma'am, I got some answers, but then in the last I don't understand what to do.
Sanya, don't worry, I have not finished the question. Doubts will be taken only when teacher has done the answer once. If I have not even explained once, there's no point of doubt. Aradhya,
Ma'am, can you do it by 7? Is 7 considered a prime number?
I don't want to start with 7. I know that it's an even number. I'll start with 2. You can start
yes,
with 7 if you want to. But
Oh yes,
again,
okay.
as I said, it's your choice. By the way, 132 is not divisible by 7.
Oh yes, ma'am. Thank you.
Janvi, what's the first prime number I should divide it with?
2, ma'am.
What should I get at the bottom?
Ma'am, 1 second, ma'am.
Shriyan, type it in the chat box. I'll not call people's names to type in the chat box. Typing in the chat box is mandatory and necessary for everyone. Everyone, please write it down. 132 divided by 2. What did you people get?
Ma'am, 611.
611, Janvi. We are dividing
I
it.
think I did something wrong.
Yes.
Oh my god.
Anvita, do you have a doubt?
Ma'am, could we also do it with 6?
No, 6 is not a prime number.
Ma'am,
We are only keeping the prime numbers on the left, Anvita. This is the reason why the name is prime factorization.
Ma'am, I sent the answer.
Excuse me, ma'am.
Sadhna,
Excuse me, ma'am. I have sent the answer. It has been 4 minutes.
I
already.
don't want people to tell me about this.
Ma'am, 66. I accidentally wrote something wrong.
Yes. Sadhna, what
66.
about the next one?
Ma'am, if we divide it by 2, it will be 33.
Thank you. Let's divide 33 by something. So, Devashri, 33.
33 divided by 3.
How much will we get?
11.
Thanks. Now, what about 11, Tanisha?
Yes, ma'am. Ma'am, 11 will be divided by 11 only and we will get 1.
Thank you. This is the place where we will stop. So, Sanya, did you get something similar to what I have written over here?
Yes, ma'am. I got till 33 and then I didn't get it.
But since this is a prime number, we will stop at 11 only and we will say 2 into 2 into 3 into 11 is the prime factorization of 132. Is that okay, everyone? Now ask if you have any doubts. Okay. Great. Then in that case, let's move into one question and then we'll go for a break. Prime factors of 6390. 6390 looks like a very big number. I could see your eyes rolling. Don't worry, it's an even number, so you can start with 2. Unique means different. Before you ask me what is unique prime numbers. Different prime numbers. So the ones which are repeated, you will not consider that.
Ma'am, I don't get it. What is different prime numbers?
Like you remember in the case of 20, what happened? There were 2 2s. Oh, oosh. 20 is the question itself. Let's do something else. Let's do 36. So 3, 12. Okay, I started with a 3. Sorry, I will start with a 2. 18, 2, 9, 3, 3, 3, 1. So there are 2 2s, Janvi, and then there are 3 3s. So what they are saying is how many different prime factors do we have? 2 different numbers we have. 2 and 3. So that's how I mean by unique prime numbers. Don't count the ones which are repeated more than once.
Okay, ma'am.
Thank you. Say Sadhna.
Ma'am, what does like the first question says, right? 6,390 as a product.
As a product like this, like we wrote over here, 2 into 2 into 3 into 3 for 36. This is the way how we wrote for the product, like this.
Okay.
Say Manasvi.
Ma'am, I don't understand this question properly.
Which question? First one?
Yes.
Yeah. So first one is saying that prime factorize it. See, these are the different ways they give it in the exam and then everyone gets confused. That's why we are doing it in the class. So as a product of prime factors means once you have done the prime factorization, multiply it and write it like this. So whatever answer you get here, you have to just multiply it and write it like this, Manasvi.
The second one?
Second one is like in a number, sometimes the prime factors are repeated. Like here we have 2 2s, here we have 2 3s. So in such cases, only count how many different numbers do you see on the left side. So I see 2 numbers, Manasvi, 1 2 and 1 3. So that's different, unique.
Oh, okay.
Okay, bye. Okay, everyone, start with the first one. First one is tricky. When we divide it with a 2, we get a big number. I think I'll go to Mishika. Mishika, what do we get when we divide 6390 by 2? Mishika, are you speaking? Naman, I'll come to you 1 second. Don't raise hand if you want to answer a question. Advika, doubt?
Yes, ma'am, I didn't understand the question.
I just explained it to Manasvi. You have to write it as the product of factors means whatever prime factorization you got, like 36 is 2, 2, 3, 3. So you have to write it like this. 2 into 2 into 3 into 3, like that.
Okay.
Okay? Mishika, say, speak loudly. Your mic is not working, Mishika. You have to rejoin. It's okay, no problem. We'll, yeah, now we can hear you.
3,195.
3,195, you said this?
Yes.
Thank you, Mishika. That's right. Okay, then Parth Padwal, tell me which is the next prime number I should divide it with.
Ma'am, 3.
Good. What do we get?
1065.
1065. Thank you so much, Parth. The next one we will do it with Naman. Naman, what's the next number I should multiply it with, divide it with?
Ma'am, 5.
Okay, we can also divide it with a 3. You know what is the divisibility rule of 3, Naman?
Yes, ma'am, we should add all the digits.
So 7 plus 5 is 12 and 12 is divisible by 3. So try to divide it by 3 and tell me what do we get?
Ma'am, wait a second.
Tanisha, what happened? Doubt?
Yes, ma'am.
Say.
Ma'am, 3,195 can be divided by 5 also.
Yeah. Both works. Both works. And both the ways you will get the same answer only, Tanisha. So don't worry. You can continue with 5 if you want. But we are following ascending order. That's why. Advika, your hand is raised. Say, Parth.
Sir, 355. Ma'am, I want to ask you a question.
You just answered the question.
No, ma'am. Is 211 a prime number?
211.
Yes, ma'am.
Yeah, so you checked it with the 6k plus 1 rule. Divide this number by 6. If you get the remainder as 1, then it's a prime number. Try.
No,
Naman,
ma'am,
continue.
I checked.
Okay.
Ma'am, the
Say.
answer is 355.
355.
Yes, ma'am.
Okay, thank you. Yeah, Parth, coming back to you. 6 times 3, 18,
Thanks.
31. 6 times 5, 30. That means 1 is a remainder. So yes, 6 into 35 plus 1. It is a prime number. 211.
मैम मैंने 2 into 3 into 5 कर दिया है एंड मैम देन into 211 मैम वो सही है
Yes, but 211 is what you got. Okay, maybe. I have not done this question part. Let me complete it. Once I complete it, then I'll tell you whether I am left with a 211 at the bottom or not. Because I don't
Okay.
think we are left with 211. We are left with a different number. Let's divide 355 by 5, everyone. So I'll do this one with Manvik. Manvik, 355 by 5.
मैम 71
Thank you. So please check your answer. You have done some calculation mistake part. You should not get a 211. You should get a 71 at the bottom. 71 is a prime number, everyone. So 71 upon 71. We write it as the product as 2 times 3 times 3 times 5 times 71. That's the answer. Clear part?
yes ma'am actually I did it 2 into 5 into 3 into that is the problem
Okay. No problem. Nanika, can you help me in the second question? Then we'll go for a break. Nanika is not there. Ibrahim,
Yes, ma'am.
can you help me in the second question?
Yes, ma'am.
Say what are the factors?
2,
Then
10, then 2, 5, then 5 and 1.
so
2
how many different prime numbers do we have?
and into 5, 3.
That's wrong.
No.
Unique means different, Ibrahim. So we will not count 2 times. We will only count it once.
I thought you told factors. How many factors are there?
Why are you listening to me? Why are you not reading the question? Okay, everyone is okay with this? Manasvi understood now? All good? That's nice. Okay, fine. With this, then we'll go for a 5 minutes quick break. After coming back from the break, we will start with HCF. Okay. The main purpose is to first understand the difference between HCF and LCM. And once you understand the difference between that, then to realize or figure out when to use HCF, when to use LCM. And once we are done with it, then you can use any method to find out HCF or LCM. Say Parth.
ma'am LCM means lowest common multiple and HCF means
No, thank you. This is not a doubt. This is an information. And guys, let's go for a break now. 5 minutes from now, okay? See you in 5 minutes. Welcome back, everyone. Okay. Now, Manasvi, I've taken few names before. Okay. I'll send you the link in the next class. Okay. Don't worry. And I'm also searching for some better materials online. If I find some better materials online, even if they are not famous, I'll definitely tell you the names. I'll send it. Okay. I'm searching for them. I'll myself purchase them and read them. If I really feel it's good, then only I'll tell. Okay. And otherwise, the basic book names I already took last class. So that Crest Olympiads and MTG, those books. Adya, we are talking about some more books to practice from. I am actually looking for that. So give me around 3 weeks time maximum. I'll go through some 4 or 5 books and I'll tell you which one I like the best. Okay, fine then everyone. Let's go. We'll get started now. And we will now do a very important discussion. So I don't want to rush. So I don't want you to complete HCF LCM today. Let's take it to the next class also. But it's very, very important for you people to know and understand the difference between the two. Okay. So as the word says, highest common factor and lowest common multiple. Factor and multiple. Remember yesterday last class when we were doing factors and multiples, the very first thing we learned was that factors are limited, but multiples are unlimited. Remember? That means whenever a question comes where the answer can be anything more than the given numbers in the question, then that is always a multiple. Like for example, Manvik goes for swimming every 2 days. Manvik goes for football every 3 days. So when will be that day when he will do both swimming and football? So for this answer, that has to be a number greater than 2 and 3, right? That has to be a multiple of both 2 and 3. And that's how we realize that, ma'am, to answer this question, we would definitely need LCM, that is lowest common multiple. But imagine numbers cannot be exceeded. For example, I have some chocolates with me. Type A chocolate is like, I have total 10 chocolates of type A, total 18 chocolates of type B. And I ask you that now tell me in how many boxes can I distribute it so that every chocolate is of equal proportion in all the boxes. Now, can the number of chocolates increase? Like type A is 10 and type B is 18, total 28 chocolates. Can I increase the number of chocolates while distributing them in the boxes? No. The 28 is fixed and we cannot go beyond it. So when we cannot go beyond it, that is the place where factors come in. Factors are limited. And in these type of questions, when someone says how many boxes should I distribute in or how many chocolates will be available in that, these questions are solved with the help of HCF. So remember, when you read the question, see, there are a lot of tricks. The tricks are look at the options. If the options are big, it's LCM. If the options are small, it's HCF. If there are keywords like biggest, highest, then we also go for the HCF. When the keywords are smallest, lowest, then we go for LCM. But see, these are applicable in 90% of questions, but there are still 10% questions which trick you on this. But if you go by this method of reading the question and understanding that my answer is going to be a bigger number, that is multiple, or my answer is going to be limited, that is a smaller number, not more than the total given in the question, then that is going to be applicable in each and every question. Okay. For example, without giving you any context, let me not give you any context and just ask you a question. Okay. I'll just put the question on the screen and you people would have to do it. Okay. 1 second. Look at this one.
Grade 6.
Look at this one. 1 second. Can I just stop the screen for a moment? 1 second. I need to remove something. Yeah. Done. I'm just sharing my screen back. Before solving this question, can you people just tell me whether we have to do an HCF or an LCM here? Type it in the chat box. Don't solve it now. First, tell me whether it is HCF or LCM and then start solving it. Thank you, Vedant. I got my first answer, everyone. Read the question and tell me whether we have to do HCF or LCM. Parth, Aditi, Aradhya, Samriddhi, Srivastav, Adrika. Good. Parth Padwal also. Okay. Manvik, Shrihan, Ibrahim, Samriddhi Singh. Okay. Samriddhi Singh and Adya, you need to check your answer. Do you really think that the number of hairbands will be increased? Like, can we increase the number of hairbands? Tanisha, correct. Devashri, check your answer. Sanya, check your answer. Hanifa, check your answer. Aradhya, it's correct. How many times will you answer, Samriddhi Singh? I just said your answer is okay. I received your answer. Naman, correct. Reyanshi, will the number of hairbands increase, Reyanshi? Don't you think the number of hairbands are fixed, whether it is rainbow, brown, or black color? Riyansh, what do you think? LCM is incorrect, guys. It's HCF. Correct, Riyanshi. So we have to find out the HCF over here. Why? Mishika got your answer. Because we cannot increase the hair bands. Hair bands are fixed. We have to distribute them. So when they ask you what is the largest possible number of girls in this group, we'll have to find the HCF. Now come to the important part. How do you find out the HCF? You must have learned some methods of finding out the HCF. So I'll be discussing 2-3 methods of finding out the HCF. Okay. And today we will wind up only with HCF. Tomorrow, next class on Friday, we will learn LCM, more word problems on that. And then I will give you the test. Okay. And today the homework is not mandatory. If you want, you can do it. If you don't understand, no problem, because you have to complete this chapter. So look at this. First method. The factors method. Factors method is where you write down all the factors of every number and then find out the highest common factor. Say, Mishika.
Ma'am, can I tell the another one?
Okay, let us write it down. First, finish this method. 1, 24, 2, 12, 3, 8, 4, 6, right? For 48, how many factors? 148, 224, 316, 412, 68, and 60. 160, 230, 320, 415, 512, 610. Any other number? Done. Now, we wrote down all the factors. Go by the name, everyone. HCF. We wrote down all the factors. Now we will find the common factors. So which are the common numbers? Let us highlight that. 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4, 6, 6, 6, 12, 12, 12. Okay. Now come to the last part. Highest common factor. So out of all the common factors, which is the highest? 12 is the highest. Don't worry, Mishika. I'm just short on time, so I'll just do all the questions. So this is called the factors method. We call it as the factors method. Is that okay? Fine. Any method? Any questions in this method? This is a long method, no doubt. Yes, Sanya.
Even one, there is three numbers, right? And then two is also three numbers. Three is there, and then four is there. And then why we only took like 12 only?
Because 12 is the highest.
Okay, thank you.
Okay. Okay, everyone is okay with the factor method? Then I'll move to the second one. Mishika, say what is the second method?
Ma'am, the number itself.
What?
The number itself.
But here the number itself will not work, no, Mishika. 24 is not the HCF. 12 is the HCF. How can the number itself be its HCF? HCF is for two numbers or more numbers. So we have to see the common number here. Say, Reanshi.
Ma'am, please can you show that again?
Okay. Guys, take a screenshot of it, please. Because I would not be able to wait. Take a screenshot of this. Taken? Ibrahim, say.
Ma'am, which sequence have you used over here? 1 and then 24, then 2 sequences.
These are factors of 24.
Okay. Yeah.
Any doubts? Anyone know, right? Okay, now focus on this. Second method. The second method is prime factorization. So what will we do here? What will we do here? We'll prime factorize everything. We'll take 24. We'll take 48. We'll take 60. And we'll prime factorize it. Match it with your answer. Then 2, 30, 2, 15, 3, 5, 5, 1. Now write all the prime factors in the way we used to write. Represent it as prime factors product. So how is 24 written? 24 will be written as 3 times 2, 3. Then 48, 1, 2, 3, 4. 1, 2, 3, 4 and 3. 60. 2 into 2 into 3 into 5. So we listed all the factors, everyone. HCF. We listed all the factors. Can we list all the common factors? Yes, we list all the common factors. So let's find out all the common factors from here. 2, 2, 2, 2 repeated in every of them. 2, 2, 2, 2 repeated in every of them. But wait, 2 and 2 are present in 2 of them. But another 2 is not present in 60. So we will not count it. But good news, 3, 3 and 3 is present in all 3 numbers. 5 is not present in all 3 numbers. So the numbers which you found out common, take them out and multiply them. What do you get? 2 times 2, 4. 4 times 3, 12. Here's your HCF. So this is called as prime factorization method of calculating HCF. Pens down. Now, if you have noted it, very good. If you haven't, take a screenshot and then tell me what is the doubt if you have any. Say, Advika.
I don't have a doubt, but I did it a different way.
How?
So 24, 48 and 60 on the top and 2 on the side. So like
Yeah. Common method. Yeah, you can do that, Advika.
okay.
I don't prefer that because it's confusing for between LCM and HCF. I do it in LCM only. But you can do it in HCF if you are not confused. But you got 12 only, no?
Yes, ma'am. But the thing is that I forgot to multiply 2, 2, and 3.
That's the problem. I don't like it for HCF. I do it only for LCF. Okay, Janvi, say.
Ma'am, you scared me, ma'am, because you like rounded 2 times 2, and then I mean like every 2 is found 3 times in all of the numbers, except in 24, except in 60 there were oh my god, I'm confusing you too.
No, I understood it. Now you got it, no? 12.
Yes, ma'am. I thought when you told there is only 2. Oh my god, I'm confusing you more. Oh,
It's okay, San. It's okay, Janvi.
I
It's
think
okay.
you got it. I
I
thought
understood
you
it.
wouldn't count 2.
It's okay. It's okay. Fine, I am not counting third too. All right, then, everyone. Is it okay? Okay, then listen to me very, very carefully. Your homework is not mandatory. If you do that, it's okay. But if you haven't done that, it's okay too. So, I am still yet to do LCM. So, technically, no homework. Let me write it down. Homework. No homework. We are yet to complete LCM. Okay. Today's date is 30th April. Okay. Done, everyone? Remember, no homework. We are yet to complete LCM. Once we complete that, then you can nicely do that HCF LCM homework. Okay. Next class, we'll do the different methods of doing LCM and more word problems on HCF and LCM. Is that okay? Yeah. Okay. By the way, I have one more thing for you people to talk about. Anvita, say.
Ma'am, you said there were 3 methods. There are only 2 methods.
Sorry.
Ma'am, you said there were 3 methods. You only told us 2 methods.
Yeah, the other method is what I'm going to talk about right now.
No, ma'am.
So that is a little bit of your mental maths. So in mental maths, what you are required to do is when you look at 24, 48 and 60, if you're really good at mental maths or if you remember the tables, like if I remember the tables of 12, you will automatically understand that, ma'am, 12 is a number which divides all three of them like that. So that's mental maths. Or else you can also take two numbers at a time and do it like that. I was about to teach that in the next class, Anvita, that when there are two numbers given to you, which are like factor and multiple of each other. Like 24 is a factor of 48 and 48 is a multiple of 24. So always remember the factor is the HCF and the LCM is the multiple. So we'll do that in the next class. Don't worry, in detail. Okay. Any other doubt, anyone? Okay, then with this comes my last question. How was the class?
Amazing.
Thank you. I know I wanted to have a match with you people, but it took some time. Don't worry, it will not take this much time in the next class. So next class we'll surely have a match. Okay, thank you. Say Anvita.
Ma'am,
Yeah, you all can leave. Those who don't have any doubts can leave.
Ma'am,
Thank you so much.
what is the homework? Where are
No
you from?
homework is written in the chat, Anvita. You're doing you're doing it from the tablet, right? You're not able to access the chat easily.
No.
Open the chat, Anvita.
No.
I've typed the homework.
Bye,
No
ma'am.
homework. Bye, Adya. Yeah, Adya, you want to say something? Sorry.
Can we play?
Ma'am, are you from Jharkhand?
Yeah.
Ma'am?
Sorry, Adya?
Ma'am, are you from
Hi, ma'am.
Jharkhand?
Yes, Adya. From Jamshedpur.
Ma'am?
Yeah, Anvita.
But after this chapter, could you please tell the homework like 3.2 or something?
Anvita, we have not done LCM. If you go to the exercise now, then you will start writing in the word, no, WhatsApp group that I did not understand. Ma'am has not covered it in the class. So that's what I'm saying, that we have not completed the chapter. If you still want to do the homework, it's your choice. It's not mandatory. There is no homework from my side because the chapter is not completed.
Okay.
You get it now?
Yes, ma'am.
Please say. Tanvi, say.
Ma'am, I know the mental maths one, ma'am. I know that 2 into 12 is equal to 24 and 4 into 12 is equal to 48 and 5 into 12 is equal to 60. So
Yes.
that's how I found it's 12.
Thank you. Say Manvik.
Bye, ma'am.
Ma'am, can
Bye.
I leave the class now?
Bye, ma'am.
Ma'am,
What,
I am.
Manvik?
Ma'am, can I leave the class?
You muted yourself, Manvik. Can you leave the class is what you were asking, right?
Yes, ma'am.
Yeah. That's what I said. Everyone, those who don't have a doubt, please leave. Bye, everyone. Thank you. Take care.
Bye, ma'am.
Bye. Take care, girls. Bye.